Good. Okay, so now that we got this to work. All right. Now, quick review from yesterday. We started with sine squared x plus cosine squared x equals 1. And that could be sine squared y plus cosine squared y, whatever, as long as it's all the same angle, yeah? Okay? Now, let's say I divide through by sine squared. What would I end up with? 1 plus, let's see, cosine over sine would be cotangent, so cotangent squared x equals, and then 1 over sine would be cosecant squared x. Or if I divided that first one through by cosine, we would have tangent squared x plus 1 equals secant squared x. Okay. It is my recommendation that we know we're going to be using these a lot today. Okay, so all the things we're going to integrate today are going to have like some version, some weird trick stuff going on with them, and we're going to, go from there. Okay, all right. So let's say I gave you this question and I asked you to integrate sine x cosine to the 6x dx. What is your gut telling you should do? I agree. And if I do that u sub, does it, theoretically, the derivative of cosine is sine and the derivative of sine is cosine, negative cosine, but it's a cosine form, okay? Which one do we want to make u in this particular case? Cosine. Why?
It's under a power.
Because the cosine is the one that's being raised to the 6th power. All right, so I'll let u equal cosine x, which would make du, the derivative of cosine is negative sine x dx. And so negative, and now this integral becomes negative the integral of u to the 6th du. I think. I'm hoping you guys agree with me. All right, now, what's the integral of u to the 6th? Negative 1/7 u to the 7th plus c. So this becomes negative 1/7 cosine to the 7th of x plus c. Do we feel okay with this? All right, now, where this starts to get a little bit less pleasant, would be how I describe it, is which one do I make my u here? And now they're both raised to a power, right? So the first one feels like a Calc 1 question. This is the Calc 2 question, though what we do is not that hard. Is everybody okay? All right, so here's what I would choose to do. In this particular question, I'm going to take my sine to the 3rd x and rewrite it as sine x times sine squared x. Why did I do that? I could do the same for cosine, okay? But when we think through whether we let our u be sine x or cosine x, right, the derivative will be then either negative cosine x dx, singular, right? The derivative of either of these as a u is a singular trig function, right? If I let u equal sine squared, then my derivative... What are you laughing at? All right, do you guys get what I'm saying here now? Okay? Now, so typically, our rule of thumb might be to take the odd power and rewrite it as 1 times an even. Now, why am I saying that? Why would we want 1 times an even instead of 1 times an odd? Well, it's funny you should ask that. But if we look through, what could we say? Like, we had a sine squared x there. Is everybody with me? What could I do to that sine squared x, knowing that it's an even power? It'll fit. I can somehow rearrange this to get there. 1 minus cosine squared. So all of a sudden, this question can be rewritten as, I'm going to write my cosine to the fourth x first. I'm going to have 1 minus cosine squared, right? Because that's what this sine squared is. And the only thing left is my sine x dx. Are we seeing why I chose what I chose? So the what I did is one thing. The why I did it is more important to me right now. Do we all see why I chose it the way I did? Okay, great. So now if I let u equal cosine x, and du would equal negative sine x dx, and transfer that negative over to the du. Now I'm integrating, now this is equivalent to the negative integral of u to the fourth times 1 minus u squared du. Are we feeling okay? What should I do next? Did anybody want to use sub it? Hey, Coop. Coop.
Yeah.
So did I the first time I looked at it, because I've my brain is tuned to doing yeah. I would call this u to the fourth minus u to the sixth du, and because then it's a little bit easier to see that, which is negative u to the fifth over 5 plus u to the sixth over plus u to the seventh over 7. We all feel good about that? Plus c. So negative 1/5 cosine to the fifth x plus 1/7 cosine to the seventh of x plus c. How are we feeling? Good? All right, let's do the one on the bottom. Beautiful question. What do you guys want to do? Split up cosine cubed to cosine squared x times cosine x. Okay. And then I would do one more thing with that cosine squared. Make it 1 minus sine squared. Great, now what? That's what I said. It's clearly 1 minus sine squared x. Okay. What do you want me to do next? U equals? Du equals? Cosine x dx. So now I'm integrating 1 minus u squared over, I'm going to call that u to the 1/2 if you guys don't mind, du. What about my bounds? What is u of pi over 6? 1/2. What is u of pi over 3? Root 3 over 2. How are we feeling about integrating this? You just split it up, yeah? So, I mean, technically we are essentially just distributing that u to the 1/2 on the bottom. So I would call, and then I would call that u to the negative 1/2 minus u to the 3/2 du. Let's see, that's 2u to the 1/2 minus 2/5 u to the 5/2 evaluated from 1/2 to root 3 over 2. And then lastly, and I would be comfortable if you left that your final answer that way. I do want it to be the exact answer and not the decimal, so if you want to check your answer, you can math 9 it and then type that expression in. As long as they have the same decimal, you know you've done it correctly. Are we feeling good so far? This is a fun one. Thoughts? Okay, so this is a new identity for you guys. It's on that, I gave it to you on that blue sheet. It's the power reducing identities. Okay, there's one for cosine, there's one for sine. Okay, so cosine squared of an angle is equal to 1 plus 2 cosine, I'm sorry, I have that 2 in the wrong spot. 1 plus the cosine of 2 times that angle over 2. So it's in one of the boxes in the bottom. Okay. No, that is an identity. So, yeah. So reduce that fourth power. So I'm going to rewrite this as cosine squared of x squared dx, which is 1 plus the cosine of 2x over 2, the quantity squared, dx. Everybody good? And then, would you guys be comfortable with me calling that, well, that would be 1 plus 2 cosine of 2x plus cosine squared of 2x on top, and then 4 on the bottom. Is that, like, if I square that fraction, right? Is that very cool? We good with that? Okay, so really I could call this 1/4 plus 2 cosine of 2x over 4 plus cosine squared of 2x over 2. I'm sorry, over 4. Oh, and then I shouldn't lose my dx probably, huh? This is starting to feel more integrable. I know it's integratable, but I like integrable better. It feels better. Let's see. At this point, I feel like I can integrate this term and this term. This one's feeling a little icky still. Ever good? But guess what I get to do to this one? Do it again. Okay. So then that would become 1/4 plus, I'm going to simplify that fraction to cosine of 2x over 2. And then, so now the cosine squared becomes 1 plus cosine of double the angle. What's double the angle of 2x? And now instead of being over 4, it'll be over 8. Because there's 4 times 2 there, right? There's the over 2 from the identity plus the 4 that's already there in the bottom. And then dx, and then are we still feeling okay? I did it different when I wrote out the notes, so now my answer doesn't match, but it does, but it doesn't. So I'm not like annoyed with myself. Are we good? All right, and then do you guys mind if I just kind of split this fraction up into like 1/8 cosine 4x over 8, right? And then maybe if I wanted to, I could combine my 1/4 and 1/8 into 3/8. If you skip some of these algebraic steps all in one, not a problem. I pulled a 1/4 out at the very beginning. I pulled this 1/4 out in the beginning of my notes. So, yeah, I don't care. You're going to end up with the same thing. So, all right, what is the integral of 3/8? 3/8 x. What about cosine of 2x over 2? If it was cosine of x over 2, what would it be? Let's ignore this 2 for just a second, not permanently. It would be sine of x over 2, right? But that 2x means my chain rule, I have to undo multiplying by 2. So it's going to be sine of x over 4. Is everybody comfortable with that? Another way of thinking about that, here, if it'll help, like if I let u equal 2x, du equals 2 du. I'm sorry, 2 dx. So du over 2 equals dx. Like there'd be a 1/2 in front of this if that with that 2 there. A 1/2 if I called it u, yeah? So sometimes I'll just divide that constant. Likewise, this becomes, yeah, sorry, it is. It's, yeah. And likewise, this will be sine of 4x. I got to unmultiply by that 4 and divide. So this will be the 8 on the bottom plus another 4 on the bottom is 32. Oh, wait. Yeah. Everybody good? We got one problem. I got a problem. Plus C. Oh, beautiful. I have this example to do, guys, and then I'm going to try to keep your work for this example kind of on the side because I'm going to throw one more example over here. Okay? All right. Thoughts on this one? I'm sorry? We could. All right, so then I would have sine to the 4th x over cosine to the 4th x. That's what you're saying? Cool. What next? It feels like it complicates it, doesn't it? Okay. instead, like I think we would eventually get there because we would then call maybe that sine to the fourth 1 minus sine, or sine squared times 1 minus cosine squared. We would eventually maybe get there, but I'm going to take a different approach if you don't mind. Specifically with tangent, I'm going to call that tangent squared times tangent squared. Why would I do that? Well, I'm going to take this into tangent squared x times what does tangent squared equal if I use my Pythagorean identity? Secant squared minus 1. And then I'm going to distribute my tangent squared. So now I've got the integral of, from 0 to pi over 4, of tangent squared x, secant squared x, minus tangent squared x, dx. We feeling okay? Now, why is that helpful? The derivative of secant is secant tangent. I agree. Is that helpful? So that would imply I'm going to let u equal secant of x. If I'm going to take the derivative of it. Like if I'm going to do u sub there. I kind of like where you're going, that we're thinking that through a little bit. I think it would be beneficial to split this up into two integrals. Okay? And Coop, well, I agree with you that maybe for this one, u equals secant x could work. It's not going to. But the next one I'm going to work is actually going to be very, very similar to what you're thinking. It's going to be different powers, though. Okay. But what do I also know? What's the derivative of tangent? Secant squared. Okay. That'd be good. So I'm going to let u equal tan x, so that du is equal to secant squared x dx. And for that first integral, this becomes u squared du. And then I say, well, what is u of 0? Well, what's the tangent of 0? 0. What is u of pi over 4? 1. That feels very doable, doesn't it? Minus. My next piece I would recommend y'all is put in these brackets because it's really easy to lose. There's one similar to this in your homework. It's a little bit longer because it's a much higher power of tangent. Okay? And I ended up having to rework it twice because I lost negative signs. So be a little bit cautious of that, okay? All right, what do you guys think I'm going to do with that tangent squared? Secant squared minus 1. You guys, what's the integral of secant squared? It's the integral of 1. We seeing it? And then what about u squared? U to the third over 3. And that one's evaluated from 0 to 1. Do we see why this one has these bounds and why this one has these bounds? And are we beginning to see how, like, because now we're gonna plug in with minus, it's really easy to screw this up. You guys get what I'm saying? Like, take the time to write it out, okay? So this first one, I get 1/3 minus 0/3 minus, so tangent of pi over 4 is 1 minus pi over 4. That's me plugging in the pi over 4. Minus, and then tangent of 0 is 0 minus 0. We seeing it all? But can you see how, like, negative signs getting lost in this can happen? Okay, now this one becomes 1/3, and then I'm going to cross out all my zeros so now it becomes 1/3 minus 1 plus pi over 4, which is pi over 4 minus 2/3. I would totally accept negative 2/3 plus pi over 4. How we feeling, okay? All right, I said I had one more that I want us to think through. Now, the reason I want to point this one out is there's I think 2 strategies to do it. Everybody okay? The first one, I think, well, what would you guys do? U equals tangent of x. Du equals secant squared x dx. So I'm really integrating u du, which is u squared over 2 plus c, which is tangent squared x over 2 plus c. We feel okay with that answer. But I've had students in the past, and the reason I'm pointing this out is it specifically happened on this exact homework assignment. I've had students in the past come up with 2 kids had used these 2 different strategies, got different answers, and caused problems for them checking with each other. And you guys really like to check with each other, right? Okay. So what they did is let u equal secant x, and du then would be secant x tangent x. So now that also would integrate, because this would be tangent times secant x times secant x, right? You guys seeing that it's the same thing of u du. And now I got u squared over 2 plus c. But now that's secant squared over 2 plus c. Now, you guys, what do we know about the relationship between tangent squared and secant squared? What's the difference between tangent squared and secant squared? It's either 1 or negative 1, right? It depends on the order. It's either 1 or negative 1. It is a constant, though, right? So while these 2 answers are not the same thing, they are equivalent when you include a random constant. And the minute I put bounds on this, the bounds of that u sub would change, right? Are we all seeing it? Like, my bounds would change the answer. And then this plus c wouldn't be, we would find this, or if I gave you an initial condition, right? If we called this a differential equation and I said, now, what is the solution if I know that f of pi over 2 equals 10 or something? I'm just making this up. We shouldn't listen to it. But when we did that, our plus c, we would get the same equation, but not the same constant. Everybody good with this? Because you guys are getting to the stage of math where you guys could all work a problem independently, all get a different answer, and they all be equivalent answers. Which is why, please give me some grace if you ask me to check your homework. Because sometimes I have to, like, think through, does your answer equivalent to my answer? But written in a different way, right? Because, again, two equivalent answers. Every good? Lovely.